So I invite Professor Apparao to please give the memento to our guest. Yukoso Amano-san, Yukoso. And now we give the ceremonial shawl as a welcome. Now I invite the VC to preside over the event and introduce us to the University of Hyderabad.
Good morning, everybody here. It's my great privilege to extend a warm welcome to everyone in this hall. The overwhelming response that we have for this Hyderabad lecture series that is organized by University of Hyderabad. At the outset, I would like to extend my warm welcome to our speaker, Professor Hiroshi Amano, who has joined us from Nagoya University, Japan. As Dean Madam has informed, he is a winner of the Nobel Prize in Physics for 2014, as all of us are aware of. And on behalf of the university and on behalf of the Hyderabad lecture series, I extend a warm welcome to you, Professor Amano. This gathering has not only students and faculty from University of Hyderabad, employees from University of Hyderabad, we have several guests, distinguished guests, invited scientists, and fellows of the Telangana Academy of Science. Like this, we have every sphere of science, different colleges, different postgraduate colleges we have covered, because the objective of this Hyderabad lecture series is to bring experts to Hyderabad and make this knowledge available or share their knowledge with all of us in Hyderabad. And therefore, we have wide range of audience here, from colleges to the academy fellows and distinguished scientists from other institutions, and of course our own faculty and students and staff. I extend a warm welcome to every one of you here. Just to tell you a couple of words about Hyderabad lecture series. This has been a generous support that the University of Hyderabad has received from Insurance Regulatory and Development Authority, Hyderabad, in 2013. An endowment has been set up at University of Hyderabad with a steering committee that is chaired by the Vice Chancellor, University of Hyderabad. And we had one lecture by a Nobel Laureate in Economics, that was Professor Amartya Sen. That was the first lecture. And now the second lecture by another Nobel Laureate, that is Professor Amano. And tomorrow, we are going to have the third lecture, that is again by a Nobel Laureate, that is Dr. Erwin. That will be tomorrow at the same time in a different venue on this campus. So we would like to appreciate the generosity and the social responsibility that was shown by IRDA, that is Insurance Regulatory and Development Authority, in setting up this endowment fund and making it possible for all of us to have distinguished speakers like Professor Amano in our midst to deliver a lecture, to share his experiences and to share his thoughts with all of us. Now I would like to tell a few words about University of Hyderabad. Many of us sitting in this room are fully aware that it is one of the top-ranking universities in the country, and this university has no affiliated colleges, and we have around 5,000 students living on this campus and doing masters and and research and postdoctoral studies. We have 12 schools of study, and in these 12 schools of study, we have a balance of both science, social science, humanities, and fine arts and other subjects as well, including management. We have an engineering school as well. This university has a recognition of growing as one of the fastest growing universities that were set up in the last 50 years. That is the distinction that this university has world over as one of the fastest growing universities in the last 50 years. And we have always been in the top ranks, whether it is a national ranking by what we call as NIRF or the QS World Rankings. In all the rankings that are there, University of Hyderabad always figured on the top. So that speaks about the contributions of university. I just would like to touch upon a small point. Recently, we were preparing our proposal for Institution of Eminence. We have realized that as for the Google Scholar citations, the research work done by University of Hyderabad has been cited close to 300,000 times, that is 3 lakh times. On this occasion, I also have to thank and especially welcome and thank also one person, that is Professor Mrityunjay Saur. Mrityunjay Saur is the head of the biotechnology and also a CEO of the Business Incubation and Entrepreneurship Cell at the Kalinga Institute of Technology, Bhubaneswar. He has been instrumental in bringing our guest to University of Hyderabad and making it possible for us to hold this Hyderabad lecture series at a very short notice. I would like to thank Mrityunjay for all this extension support that is given. With these few words, I don't want to take too long. I will again request Professor Bindu Bamba to formally introduce a professor of Nagoya University. For a short while in between, he went to another university and he is back with Nagoya University. And I'm sure Professor Bindu will give a detailed introduction of our speaker to the audience. Professor Bindu.
Ohio gozaimasu. We welcome you warmly to the University of Hyderabad and to the School of Physics in particular. We at the School of Physics have always had very close ties with Japan. We have had many of our faculty having very fruitful stays in Japan, including Professor Rajaram, Professor Mahanta, Professor Dr. Venkatayya, and Dr. Rajnikant. And 2 of our faculty members are actually fluent in Japanese, so that is nice. Many of our students have gone to Japan for their PhDs, and we are in awe of the contributions of your great country. So we aim to make academic excellence a hallmark of the School of Physics, and it is in this spirit that we find it imperative to develop effective programs in physics that will prepare our students to excel in the existing areas and to enter new fields of specialization. For these, we need to have interaction with scientists like you, Professor Amano, because the lasting contribution to knowledge that you have made and can serve us and guide us in our mission. So in particular, we would like to learn from you how to foster a synergetic relationship between academia and industry that you have done with so many industries in Japan. So this will enable us to offer diverse and flexible tracks for our students and make physics more attractive, physics and electronics more attractive as an academic field for our students. So Professor Amano was born in Hamamatsu, Japan, which is also the birthplace of the starter of Honda. So we all know about Honda, so it is Honda City. And so he received his Bachelor of Engineering, Masters of Engineering, and his doctorate from Nagoya University. He was very athletic in his school days. He played soccer and softball, and then he became the top student in his school. From 1988 to 1992, he was a research associate at Nagoya University. Then he moved to Meiji University, where he was an assistant professor, and then he returned back to be a associate professor at Nagoya University and is now a professor at the Graduate School of Engineering in Nagoya University. He joined Professor Isamu Akasaki's group in 1982 as an undergraduate student. And then he started doing, as an undergraduate, the research on growth characterization and device application of group 3 nitride semiconductors, which are known as the materials that are used in blue light emitting diodes. In 1985, he developed a low temperature deposited buffer layers for the growth of group 3 nitride semiconductors on sapphire substrates, which led to the realization of group 3 nitride semiconductors based light emitting diodes and laser diodes. In 1989, he succeeded in growing P-type gallium nitride and fabricating a PN junction with gallium nitride based UV blue light emitting diodes. This was done for the first time in the world. He's very keen on research, and his laboratory is known as the No Night Castle because the lights are on for 24 hours and the research goes on in his laboratory for 24 hours. He has won many awards, the icing on the cake being the Nobel Prize for Physics in 2014, but every other award that you can think of in the field of electronics and he has won. And he has won many honors, including the Order of Culture of the Japanese Empire. We are really very happy to have you ever since we looked at the new LED TVs because they have absolutely revolutionized our lives. And blue light emitting diodes have brought lots of joy to all of us who own nice TVs and nice cell phones and the airport lighting and everything. So they brought a lot of joy to us. And we are very happy that you are here with us, and welcome.
And good morning. I'm so surprised that so many people are getting here. And I'd like to thank first the deputy director and the staff of the University of Hyderabad for giving me this very excellent opportunity. And also, I would like to thank for inviting me here. Yeah, today I'd like to explain why the blue LED is so important and so why it is so difficult to realize and how the blue LED affect your life. And also I'd like to explain what we are now doing. I have two subjects. One is how to provide the safe water using the electronics. And the second thing is we are imagining the next social system. We call it the Internet of Energy, not the Internet of Things. So today I'd like to explain the three topics. But before starting my talk, there are many young students are joining this lecture. So first I'd like to explain what will happen if you become the Nobel Laureate. Okay? Yeah, in 2014, these three persons get the Nobel Prize. He was very famous. He has been nominated as the candidate of Nobel Laureate for more than 10 years. Okay? He was my supervisor. His name is Professor Isamu Akasaki. Okay? He is also extremely famous. All the nitride researchers know him. His name is Professor Shuji Nakamura. Okay? But he is nameless. So, yes, The Nobel Award ceremony is always held in December 10th. It's an anniversary of the passaway of the Alfred Nobel. But 2 months before, the announcement was held. There are many things we should prepare. So it's a time of October 7th that the announcement was held. Yeah. Okay, to tell the truth, when the announcement season comes, always many journalists and the TV staff came to our office and waiting for the announcement that the Professor Akasaki received the Nobel Prize. And always I was asked to the journalist staff that if the Professor Akasaki received the Nobel Prize, we will request you the good comments. So please prepare the good comments for him. And I enjoyed such a situation in the first year and the second year. But 3 years have passed, 5 years have passed, 7 years have passed, and 10 years passed. I was a little bit tired of such a situation. So I decided to go abroad without informing to the university. Announcement was done during my flight from Nagoya to Frankfurt. Frankfurt was the transit. And then I opened my PC and found I received many emails entitled "Congratulations" and the "Omedetou gozaimasu" in Japanese. But unfortunately, no one explained why it is so happy. So I could not understand the reason why I received such a large amount of emails. So I thought that they should be a spam mail. So with fear, I went to the final destination, the Lyon airport, and found at the exit there are many Japanese-like journalists waiting for someone. So I thought that, I was very lucky. There may be or should be very famous movie stars are getting on the same plane. And then I went through the journalists, and one of the journalists came to me and said, "Are you Mr. Amano?" "Yes." "Do you know what happened?" "What?" "You received the Nobel Prize." Wow. Okay, so there are some there are some problem in our laboratory. I was not here, so the mass media interviewed my laboratory without me. This is only the photo. And the problem is the Nagoya University. I was missing at the press conference in Nagoya University. The next day, I visited Minatec, France, and I was asked to comment on the impression about the receiving the Nobel Prize, but I could not remember what I talked because I was still very astonished and I could not understand what had happened. But only thing I could remember in November 8th is one of the trustees called me. Yeah, they catch me and called me and said, the Professor Kunieda said, "You went to France with the economy class flight. For return flight, you should use the business class." That's the only thing I can remember. And then I returned to Nagoya on October 10th, Friday. I met with the president and the other trustees at Nagoya University, so I was so happy to see them. And the next day, it's a Saturday, October 11th. There was a wedding ceremony of my former students at Sendai. So we celebrated each other. And in October 12th, it's a Sunday, I went back to my office and found many emails. And in the email, I found the email from the Nobel Foundation. Okay, to tell the truth, until then, I never contacted with the Nobel Foundation. So I read the email very carefully. They said, yeah, we, the Nobel Foundation, tried to contact with you via email, telephone, and facsimile, but there is no response from you, me. If in future there is no response, there is a possibility of cancellation. So I was so astonished and tried to call to Nobel Foundation, but there is no response from them. Wow, what happened? But soon I understood the reason. It's a Sunday. So I wait until Monday morning and then call it again, but still there's no response. The fear again. But soon I understood the reason. There is a time lag between Japan and Sweden. So I waited until 5 p.m., then call again, and very luckily I could get the response from the Nobel Foundation. Okay, that's my funny story. Yeah, from now on, I'd like to speak about the serious research topics. How to achieve the writing revolution. Yeah, the first commercially available LED was red LEDs, which was invented by Professor Horoniak, the United States group. They used gallium and arsenide compounds, and it was 1960s, and in 1970s the green LEDs was commercialized. The material is the compound of gallium and phosphide. So if you studied the quantum mechanics, it is very easy to imagine what's next. Please imagine the periodic table of the element. Gallium arsenide for red, gallium phosphide for green. So next should be gallium nitride for blue. So many researchers in 1970s tried to commercialize the blue LEDs with gallium nitride. But in 1970s, all the efforts failed. It was very difficult to get or to grow good gallium nitride crystals, and it is very difficult to realize P-type gallium nitride. And also, it is almost impossible to grow indium gallium nitride for luminescent materials. So, unfortunately, many famous worldwide researchers abandoned this material, except one person. Why it is so difficult to grow gallium nitride? We need a very high pressure and high temperature to synthesize the gallium nitride, which is similar or even difficult than diamond synthesis. So we have to use the foreign material like sapphire as a substrate. But the problem is the lattice mismatch. It is as large as 16%. In general, in the semiconductor crystal growth, the mismatch should be less than 1%. So many people abandon these materials. But one person could not abandon. His name is Professor Isamu Kasaki. He is studying the material research from 1967. at the private company. But very, very unfortunate that the manager of private company decided to quit the project of nitride because it was too difficult. So Professor Akasaki have to move from the private company to National University in Japan in 1981. And I joined his group as the undergraduate student. When I saw the research subject, the nitride-based blue LED, I was so excited. The reason is, at that time, I was interested in the micro or PC, microcomputer system. Now it's called the PC. In 1975, Microsoft was established by Bill Gates, Paul Allen, Apple One by Stephen Jobs and Stephen Wozniak. So from this success, the microcomputer system is expanding to the market pretty much. So I would like to contribute to the further development of the microcomputer system. And the display is also one of them. Yeah, the people sitting in front knows what kind of display was used in 1980s. All the displays is brown tube or cathode ray tube, which is very big, very deep, and they need a lot of electricity. So, as a student, undergraduate student, I thought, if I could achieve blue LEDs, I would change the world. That's why I could concentrate on this research topic. Okay, Professor Akasaki moved from the private company to the National University. At that time, the National University research funding is pretty poor. Okay, so if we try to buy equipment, we need at least 50 million Indian rupees. But the funding of Akasaki laboratory is 1.5 million Indian rupee per year. So of course, we could not buy new equipment. Then the student tried to develop our own equipment by ourselves. Okay. This is, yeah, I'm very proud. It's only one of the kind, unique MOVP reactors, which was developed by ourselves. This is the beer bottle. Beer bottle is very important, not for drinking. Okay. For heating, we use the inductively coupled coil. So we need a coil, but coil is very expensive. So what we have done is we bought the straight capacitor, which is very cheap, and then heating it and winding it to the beer bottle, we can fabricate a very nice coil. In such a way, we could start the research on gallium nitride. It was good old days for the young student. In the laboratory, nobody knew about this new technology. So even the beginning student like me could freely discuss with no hierarchical relationship. So it's an equal relationship. So the students could independently proceed the experiment, and the students tend to feel the responsibility for their research results. And for me, the most important thing is Professor Akasaki always encouraged me by saying that you are the best person who knows the MOVP growth of gallium nitride. So always I was motivated with his suggestion. But undergraduate, the first year of master courses, second year of master courses, 3 years have passed without any improvement, any success. So I have done more than 1,500 times of experiment without any success. But there's the hint from the discussion in the laboratory. The young Professor Sawaki always discussed with the students, and he said the insertion of some different materials sometimes leads to the improvement of crystalline quality of the heteroepitaxy. Then I used the low temperature buffer layer, and from the first experiment, I got the world's best quality gallium nitride on the sapphire substrate at that time. So I was so excited and wrote the patent and also wrote the journal papers and submitted to applied physics letters, and it was very easily accepted. So I was so excited and thought that this paper should take notice of researchers all over the world. But it was my mistake. No one are interested in these papers. The reason is at that time, in the mid-1980s, the many blue LED researchers were moved from the nitrides to other materials, that is zinc selenide. And the gallium nitride researchers are very, very minority, only 1 or 2 groups all over the world. But anyway, in such a situation, I could concentrate on this material. So I became the doctoral course, I entered the doctoral course and tried to realize the P-type gallium nitride without any success. I used the zinc as the dopant, but zinc is inactive in gallium nitride. And I found some interesting phenomena. By electron beam irradiation, blue luminescence was irreversibly enhanced, but still it's not a P-type. So at that time, we should write at least 3 journal papers to get the PhD. I wrote 2 papers, but the remaining 1 paper I could not. So I could not get the PhD within 3 years of the doctoral courses. But I'm very happy that the Professor Kasaki intended me to become the research associate. So I could continue the research. Then found that, in the textbook, I found that the magnesium should be better than zinc in terms of the activation in green material, gallium phosphide, and found my mistake. Then I switched to magnesium and realized the world's first P-type and PN junction LEDs. It's a very tough work. At that time, Nagoya University didn't have the equipment for electron beam irradiation, so it took 1 hour by a small scooter to go from Nagoya University to the company, to the Gosei, and it took 7 hours for treatment and went back to Nagoya University. So for 1 sample, I need 9 hours. And then went back to Nagoya University and fabricated it, and we could realize fast PN junction LEDs. I could observe the fast PN junction very, very bright. And also, my colleague, Mr. Kita, also observed the emission. But most important thing is Professor Akasaki recognized. So I took the Professor Akasaki to the experimental room and showed him. But the first talk of him is, oh, where the light was coming? Yeah, unfortunately, Professor Akasaki could not recognize the emission. Yeah, we understood the reason. The first PN junction diode emit UV light. Okay. In general, eye sensitivity, human eye sensitivity shift from shorter wavelengths to longer wavelengths with age. Do you know that? So, young generation like me can recognize, but unfortunately, the elder person cannot recognize the UV emission. So, we try to modify the emission, and finally, we could realize the bright blue emission even under the illuminated room. So, I could write the third journal papers, and then I could get the PhD. Okay, so in 1997, world's first commercialization of blue LEDs was realized by Nichia Group, led by Professor Nakamura. Okay, I'd like to emphasize why you can enjoy the smartphone, the full color smartphone, is because of the emergence of blue LEDs. We need three primary colors, blue, green, and red. But also I have to emphasize that this is the blue LEDs. And some people think that the white LEDs, commercially available white LEDs, is composed of three primary color LEDs, blue, green, and red. But it's a mistake. Okay? In the white LEDs, only blue LEDs was used. No other colors is used. Only the blue LEDs can realize the white. The other colors, the red LEDs and green LEDs, it is impossible, almost impossible to realize the white. So, people think, the researchers think, oh, it can be used as the general lighting system. Okay. So, efficiency of these white LEDs drastically improved. Now, the efficiency of LED lamp is 10 times higher than that of incandescent lamp and 2 times higher than that of fluorescent lamp. So by replacing the old lamp to the LED lamps, you can reduce the electricity consumption, or you can reduce the CO2 emission. In case of United States, by year 2030, our three quarters of the general lighting system will be replaced to LED lamp system, by which you can reduce the electricity consumption by about 7% of the total electricity consumption. In Japan, the penetration is much, much faster. By year 2020, we can reduce total electricity consumption by about 7%, which corresponds to 1 trillion Japanese yen. The more importantly, according to Nobel Foundation, the LED lamp holds great promise for the increasing the quality of life for over 1.5 billion people around the world who lack access to electricity grids. Due to low power requirements, it can be powered by cheap local solar power. Yeah, the year 2015, the Minister of Science and Education, Mongolia, visited Nagano University and said, "Thank you so much." The reason is, according to him, the traditional lifestyle of Mongolian people is the nomad life. They do not use the fixed house. They use the tent, which is called the gel. So in 2016, I visited one of the family of Mongolia and found that I took this picture. I saw that they really use the LED lamp. I was so happy to see that. Okay, that's my blue LED story. And next, I'd like to explain what is next. It is the deep ultraviolet LEDs. My turning point from blue to UV is during my sabbatical at the National University of United States. In aged 38, I visited Sandia National Laboratory, United States. It's Albuquerque, New Mexico. It's just in the desert area. Yeah, to tell the truth, before visiting Sandia National Lab, I had thought I would be superior to them in terms of blue LEDs and gallium nitride research. But soon, when I discussed with them, I found my mistake. During 3 months of sabbatical, I learned a lot about very high creativity and sincerity of Sandia people. So I changed my mind. I heartily decided to contribute to mankind even more than them. But how to do that? As you know, the Earth is the water planet, but the ratio of the water we can use is very, very limited. It's only 70 ppm for fresh lake water and only 2 ppm for river. And according to the UNICEF, still 660 million people lack access to improved drinking water, and 2.4 billion people do not use an improved sanitation facility. And global warming causes the increase of bacterium in drinking water. So water is very important. So, especially for young students, how to clean up the water. There are several methods, but I'm thinking to fabricate the new light source, UV light source. First problem is the funding, research fund. I had no funding, so I applied to this Fundamental Research Fund, Ministry of Education, and very likely I got the fund from them. But unfortunately, the funding size is not sufficient to buy a new equipment. So I went to the company, maker company, and finally they decided to support us with a very reduced charge of their equipment. Also, we have to use the very special spare parts, which is tantalum carbide. Very, very expensive. So I went to the company, and finally they decided to supply us free of charge. Then the Epic West and Evident supported us a lot. So we succeeded in growing high quality crystal, and next I applied the Applied Research Fund. It's a Ministry of Industry, so the size is bigger. Then finally we could get the fund by private bank for private company. Oh, this is one of the examples. It is already used. I don't know whether you enjoy the oysters, but in Japan, there are many people enjoy the oysters. For cultivation of oysters, our UV LEDs were already used. Yeah, the last year, January, I visited Guatemala and heard that they have the problem of water contamination of lake. The Lake Atitlan and Amatitlan they use as the drinking water, but it was contaminated by the cyanobacterium. So we decided to collaborate with them, the university, the buyer people, and the Nagano University team collaborate to purify the water for the young, especially for the young generation. Okay, what's next? We call it the transformative electronics for realizing not only the Internet of Things, but also the Internet of Energy. Connect at any time and place without wire. The Japanese have the problem of the increase of the CO2 emission by electricity generation because we have to shut down the nuclear power plants. So the fossil fuel ratio increased from 62% to 89%. That's the serious problem for us. Yeah, LED is very energy efficient, but the ratio of electricity consumption by lighting is only 14%. The majority is air conditioner and refrigerator. It's close to 60%. So for electricity consumption reduction, control of the motor is more important. Okay? So this subject, the Japan company has the priority. Yeah, according to Daikin, they use the inverter control system, inverter circuit system, by which we can reduce. This is the mechanical control system, and this is the inverter control system as a function of input power. By using the inverter control, we can reduce the electricity consumption a lot. In Japan, all the company uses the inverter control. It's 100%. If you look at the other Asian country, it's, I don't know in India, it's only 17% in general. United States, it's only 11%. So people have to use the inverter more. But still, even the inverter have the problem. In general, 5% loss. So how this loss affect the electricity consumption? If you use the solar panel to operate the PC, you need to use a power conditioner, DC or DC to AC converter. You have the loss of 5.5%. And AC adapter, it's a 7% loss. So if you touch the AC adapter, sometimes it's hot. The reason is the loss. Okay? And in the PC becomes hot. The reason is the loss. It's 5% and 12% loss. So even though you generate 82 watts, you can use only 60 watts. So about a quarter of the generated electricity is lost. It is like a remittance charge of bank transfer. So our goal is to reduce the remittance charge to zero. Blue LED material, gallium nitride, is very promising. Why? The breakdown field is 10 times or 40 times higher than that of silicon. So we can reduce the device size 1/10. So the loss 1/10. It's very simple. So we can reduce the total electricity consumption by about 10% by replacing silicon-based conventional transistors to gallium nitride-based transistors. Yeah, now the age changed to 4G to 5G. For 5G, very, very quick response is necessary for autonomous driving. Okay? For autonomous driving, if you drive the car at 100 kilometers per second, the response time from the server should be less than 1 millisecond. It is because of the shortening time. The 1 millisecond means a 10 centimeter move. Okay, within 10 centimeter, the server responds. And also, Internet of Things, many things Internet is connected. So it's more than 1 million clients per square kilometers. Only this material can meet, only the gallium nitride device can meet this demand. Okay. Yeah, in future, we can connect wirelessly. Of course, there is the wireless connection of the iPad, iPhone, but it is magnetic control, so we need a coil and a very expensive material. In future, we can connect with a very high frequency, which means the size of the device can be minimized, very small. So we can connect at any place. And the remote connection is possible at anywhere in this seat and anywhere in the desk. We can connect from the source to the device. This can be used for future logistics by drone. The drone is very interesting, but the problem is the flight time is very, very short, only 20 to 30 minutes. And the charging time is more than 1.5 hours. That's the problem. So if we connect wirelessly, yeah, we can operate or drive the drone 24 hours a day. Okay. Next generation mobility and logistics should be like that. Pilotless drone for logistics, air commuting system with a pilot, and air taxi. Okay. This air taxi is very important, especially for aging, the country which have the aging problem, like Japan, Germany, or Italy. The average age is increasing. The problem is the mobility is decreased. So to support the elder person, air taxi should be very, very important in future. Okay, so I'll try the movies. So this is the electric field connection without wire. The energy is transmitted from the the simple panel to the panel which have the LED light. Okay. If there is different dielectric materials, it easily disconnected, so it's very safe. Okay. So, we are imagining the sustainable and smart society, but how to realize that? In Nagoya University, we established a the organization, the gallium nitride research consortium, and at present, 44 private companies, 20 universities, and 3 national institutes are joining this consortium. The concept is from the crystal growth to the system. It's open platform, industry, government, academia, and from the fundamental research to the applications in the one roof concept. Okay. Yeah, we will now establishing new clean rooms. It's 1,000 square meter, and which is only dedicated to gallium nitride. And we have transformative electronics commons. It's an open space, open innovation space. So anyone, if you are interested in, you can come and join us. So what we need? Young students and researchers, research partners, investors, and the venture entrepreneurs. So if you are interested in, please contact me. Okay. Thank you so much for your kind attention.
Well, we had a wonderful lecture, a lecture that has taken us through the journey that he has passed in achieving the Nobel Prize, and subsequently what this technology can do for the world also he has talked about, and towards the end he has also indicated the ways in which anyone in this audience can join them and work with them if we have some innovative ideas. But I know it is not customary for this kind of big lectures to have question and answers, but it is a rare occasion to have a distinguished speaker like him with us. I would like to allow maybe a few questions, if they are very, very tempting questions for anybody sitting in the audience. A few questions I hope Professor Amano will be able to take. Oh, is that okay, Professor Amano? Will you take a few questions? Yeah, please take a seat. Yeah.
I'm Prithviraj. I'm a political science student here, not from the sciences. So basically, I have the physics background. So, Professor Amano, you have mentioned in your research papers that aluminum gallium nitride based deep UV LEDs are effective for the sterilization and purification of water. So my question to you is, how will this invention rescue those 663 million people who still lack the access to safe drinking water, and 2.4 million people you mentioning do not or cannot use safe sanitation facilities, when dissemination of this technology at a commercial level is still a costly affair? Like simple bottle, this embedded technology costs around $50 in the recent markets.
Yes. Okay. The water purification is not the easy technology. We need a lot of technology to purify. bacterium sterilization is only one of them. But for example, in liquids, the first step is the desalination from the seafood. And also, the important point is the first investigation of the quality of the water first. What kind of contamination is most serious in the water? So we are trying to develop a new water purification group. And we need a different kind of specialists, not only the electronics, but also chemists and biologists. So in such a way, we could treat the contaminated water. But we need a long time because the investigation is very important, but not so easy. So first step is the investigation of the water quality, and then try to verify. One of the advantages of our system is we can use it at home, not a big size. It's a very small size, so we can use at home. But sometimes we need a very big system of equipment or bigger water purification. So it depends on each area. So so the gathering different kind of specialists is very important for providing safe water.
Can you throw some light on the radiation methods of this UV transmission?
The radiation program.
The radiation methods to human health. When you start reading about
UV radiation. Effect of the UV radiation. Yeah, that's true. We know that the UV radiation destroys the DNA of the bacterium. But maybe the effect is not limited to the destroying of the DNA. There are some other effects. So we have to be careful if it is irradiated to human. So we limited the radiation only to the water or to the air. There are different kinds of bacteria, and UV radiation is effective for Legionella or other very common bacteria. But some bacteria, it is very strong against the UV light. For example, the influenza bacteria, it is very strong to the UV light. So we have to irradiate more. So, for the real application of the UV light, we need a further investigation. Okay.
I have a question. In the area of VLSI fabrication. VLSI fabrication.
VLSI fabrication, okay.
UV sources, good UV sources are required to realize the photolithography. Right?
Yes.
They use excimer sources and things like that.
Yeah.
Do you see a possibility of your UV LEDs finding an application in that area?
Oh, thank you so much for the, yes. Our blue LEDs are already used for the commercial maskless fabrication system, but in very near future, the problem is the intensity is still insufficient for the efficient wide area photo processing. But in the very near future, we can replace from the blue LED to the UV LED, right? So we can probably much tiny process. Not by 2 years, but yeah, for quantum semiconductors, we already use the blue photo lithography process. It's a maskless process, so it's very easy to fabricate a new structured device. Thank you so much.
The concept of Internet of Energy. The concept of Internet of Energy.
Energy.
To transmit power to free space. Is UV the right frequency range or microwave and the low frequency range is better?
The point is the energy transmission or?
Yes, energy transmission, if it transmits in UV, atmospheric acceleration will be very high. And,
Yeah, not UV. Yeah, we will use the microwave. Yeah. The microwave and the laser. Yeah, for short distance. For example, electric field covering is limited to 10 centimeter to 20 centimeter at most. The microwave, we can transmit energy up to 100 meters. And for lasers, we can transmit the energy to over 1 kilometer. So it depends on the distance.
yes, but again, the environmental aspect, if we use microwave for power transmission, intensity is going to be high. It is going to have environmental effects.
The high energy, high density causes some trouble. Trouble. Yeah, of course. that's a serious problem. So, yeah, how to transmit the energy with safety is a very serious problem. So, for example, the electric field covering case, if the different dielectric material is inside it automatically cut. And the response time can be less than 1 microsecond. So in such a case, maybe the effect is not so serious. But if we use a microwave connection, we have to check some material inside it or not. And we should cut within 1 nanosecond or very short time. This is the next generation, the very important technologies. Thank you for your
Hello sir, this is Subaru. My question is sustainable developing smart society. In the partly we are using Android phones like smartphone. So smartphone is everything might come from Android. If Android is going to lost, people are going to die in the pockets. It's going to blast, unfortunately. So point number 1. And the point number 2, and the blue LED, the partly of red LED, as we are establishing the sustainable developing smart society also, we are developing the thermal, nuclear, electronic power plant project. So it is the more releasing the radiation to the human arms. So how can we protect it?
Yeah, you have 2 questions. Yeah. Okay, but I could not catch both of them. Oh, really? Okay. Our radiation is, if the density is low, no problem. For example, the radiation, you know the blue-white problem, right? Blue-white problem. No? Yeah, if the blue-white is too strong, it affects the human life. But the LED lamp the blue light intensity is very safe, not so strong. And it's different from the nuclear radiation. Nuclear radiation affects directly to the atom. But our radiation is quite different. It's only photon or light, very low energy, and vibrate, much lower energy. So, but as someone mentioned, if the density is high, it affects the human body. So we should be careful against such a radiation.
Yeah, there was one to the end, yes, towards the end there. Yes, yes, please. I would like to give opportunity to the guests first, because after lunch there is an interaction session for the faculty and students from the university, which is arranged in the UPE the Dr. Zakir Hussain Lecture Hall complex. That also you can avail. The guests, please.
Yeah.
Good afternoon, sir, and thank you for visiting our university and spending your time with us. Sir, my question is not regarding the science. I wanted to become a teacher. So suppose if you are my student, what you are expecting in my teaching and in my personality?
Okay. Let's try. I became the student and you are the teacher.
Yes, over there. Wait a minute, take the microphone.
So you mentioned we can achieve this white energy by two methods, either by constantly mixing the red
Yes.
and the other is using this yellow phosphor screen what you showed. Yellow phosphor screen on the
Yes.
Sir, yeah. Sir, my doubt is, sir, sir, I might be wrong in the question as well. Sir, yellow phosphor screen itself might absorb some of the energy. Sir, how is it more energy efficient than conventional mixing of blue, green and red?
As I said, okay. The efficiency of this, absorption efficiency is over 97%. So, almost all the blue light is absorbed here, but it depends on, of course, the thickness. If we can control the thickness, we can reduce the absorption. So to control the ratio of blue light and yellow light. So at the very beginning of the blue or white LED commercialization, the white is not real white. It's very bluish white. But now we can control the spectrum pretty much. So now we can provide any kind of white light. The real white light, even the real white light can be possible. White means the front spectrum all over the wavelengths. So it depends on the material, the technology of this phosphorus.
So my point of asking was, if we traditionally mix the red, blue and green and get the white, there is no absorbance due to any other material. So how is it less energy efficient than using a screen like this?
Energy efficiency. Okay. Yeah, there is a fundamental problem of stop shift. We cannot go over to the stop shift. For example, the blue light photon have the 2.4 eV and the red light 2 eV. So the maximum efficiency is 2 over 2.5. It's the maximum. We can realize that, but we cannot overcome the stop shift loss.
Okay. Thank you very much. Thank you, Professor Amano, for addressing all the questions as well. And I would like to Please take seat. I would like to request every one of you sitting in the auditorium to put your hands together to applaud the lecture. Thank you. Thank you. That is in appreciation of the wonderful lecture that you have given to this university and under this Hyderabad lecture series. Now I request Professor Srinath to propose vote of thanks.
Good afternoon, everyone. Honorable Vice Chancellor, Professor Apparao Garu, Dean School of Physics, Professor Bindubamba Garu, our distinguished guest, Professor Hiroshi Amano, my colleagues and students, and all other invitees of this Hyderabad Lecture Series event. It's my privilege to propose a vote of thanks on this occasion. I, on behalf of the School of Physics and University of Hyderabad, extend my heartfelt gratitude to our distinguished speaker, Professor Hiroshi Amano, for sharing with us his pioneering work in the invention of efficient blue light emitting diodes, which has enabled bright and novel energy saving with white light sources. You have inspired us by all your work and research contributions in enriching the lives of people. We would like to extend our gratitude to Dr. Mrityunjaya and Dr. Suraj Tripathi of Kalinga Institute of Technology for coordinating with the University of Hyderabad for this event to happen. I would like to take this opportunity to thank our Vice Chancellor, Professor Apparao Garu, Dean School of Physics, all our colleagues for their total involvement, presence, and support. I would like to thank the bevy of students from School of Physics for their help, and also the students of Life Sciences for distributing the flyers to all educational institutions in and around the Twin Cities. We would like to thank the committee members of Hyderabad Lecture Series for readily agreeing to sponsor this event. We gratefully acknowledge the services of PRO, Estate Office, Horticulture Department, and all other administrative sections for their support. I would like to thank the media for covering the event. And finally, I would like to thank all the students and participants from the university and various other institutions for their enthusiasm and presence, making this event a grand success. I also thank all those who have directly or indirectly helped in the smooth conduct of this event. Thank you.